Okay, so, right, that's an example of maximizing revenue. And it's not really anything deep. We've got revenue equals price times quantity is the big new thing. There are problems in the homework that also involve throwing the profit into the mix. Maybe I'll give you a revenue and a cost function and say maximize profit. So you need to write down what the profit is. It's revenue minus cost, and then maximize that same way we've been maximizing things. Maybe I'll give you the demand curve and say maximize profit. So you need to use the demand curve to write down the revenue using this, and then write down the profit using this, and then maximize that. Like there's a few build the function and then maximize it things, and they're a lot simpler than they were with those gross area of the pasture type problems. And so by and large, these are like easier versions of the last optimization stuff we were talking about. So we want to now sort of zoom in on revenue. Usually you want to maximize profit, but there's times that you only want to talk about revenue instead of profit. One of these times is maybe I don't know what the costs are. Maybe the costs vary a lot over time, and we don't want to factor in any permanent function into our maximizations. Maybe this boat example is a pretty good one, where I guess more people on the boat might cost a little more gas, but by and large, taking a boat out on a tour, the number of people on the boat doesn't really matter. The costs are almost fixed, or maybe the costs are so low that they don't really affect things. We want to focus on revenue. And if I'm a company, what do I want to do with my revenue? I probably want to maximize my revenue. And I want to think for a second about what happens to my price and my quantity. Like if prices go up by 5%, if you know how percents work, increasing your price by 5% means multiplying your price by 1.05. If your price gets multiplied by 1.05, then you're just sticking a 1.05 into that formula, and that causes your revenue to go up 5%. Except that it usually doesn't, because when you jack up the price, the sales are probably going to go down. Do they always go down? When I drew that demand curve, I drew it as a decreasing function. A decreasing function means that when the price goes up, the quantity goes down, or when the quantity goes up, the price goes down. Like, it should be decreasing in either direction. This is one of these rational market assumptions that they say in economics, where if you charge more, people should want to buy it less. This isn't always 100% true in real life. There's a thing called conspicuous consumption, where rich people want to buy expensive things not because they're better, just because they're more expensive. Like, in part because they are assuming that it's better, but I guess the point of conspicuous consumption is that you want people to see that you bought an expensive thing. The expensiveness is the point. Like, the expensiveness is a desirable trait. You got one even more expensive? Yeah, give me that one. Or there's like an alternative, like the flip side of that is sometimes you avoid buying the cheap thing, not because you think it's worse, but just because it's cheap. Like if I'm at the store and all the deodorant costs $5 and this one costs $1.50, I'm like, what's wrong with this deodorant? Why is it so cheap? The cheapness becomes a turnoff in certain circumstances. Anyway, we're by and large not thinking about that. We're going to assume that when you increase the price, that always causes the sales to go down. So when my price goes up by 5%, what happens to my sales? Maybe my sales go down by 4%. Is it worth it if my price goes up 5%, but my sales go down 4%? Sales going down cause my revenue to go down by 4%. When I affect one of these things, it causes the other, and I want to compare which one wins, which one was the more important thing. And by and large, it's the bigger one, whatever the bigger percent change is. And the percent part's important. If the price goes up by 5 cents and the sales go down by 300 units, which one wins? I don't know. It depends what the price is and what the quantity is. But if I express these things as percents, then they are directly comparable. This 5% is bigger than that 4%. And they both cause a 5% and 4% change to the revenue. And if you go up 5% and down 4%, I think you're out ahead a little bit. So, you're not ahead by exactly 1%. It's a little gross. You got to multiply 1.05 and divide by 1.04, and finding the real percent is gross, and that's not the point of this. The point is, comparing these percent changes is useful. So, we have a word that talks about this comparison, and that word is elasticity. Or if you want to be specific, it's elasticity of demand. In an economics class, you might have like 5 different versions of elasticity. The thing I remember most from my economics classes, you would talk about one idea, and then you would apply it to all these 5 different contexts, and they were all basically the same context about supply and demand, but supply and demand from different people's perspectives. If I'm HR, then I'm thinking about the supply and demand market of hiring people. So what does the elasticity mean in that context? We're going to talk about elasticity of demand of people buying things, presumably things we are making. And the definition of elasticity is you talk about the percent change in quantity, and you divide that by the percent change in price. These are those 2% we were talking about. If your sales go up by 5% when your price went down by 3%, then your elasticity is 5 divided by 3 is 1.4. Except we throw in a negative sign, because one of those 2% changes has to be negative under our rational market assumption. So the elasticity, if I just divided the two things, I would always get a negative number. One of those increased and one of them decreased. We stick a minus sign out front to make elasticity a positive number, because it feels dumb to give a name to a thing that's always negative. Is there an example of that? I don't know if there's an example of that. I can't think of one. I'm going to usually shorten this by percent change in Q divided by the percent change in B. I'm going to use delta for change in. So for example, do I have an example written down? I can sell 500. What am I going to sell? I'm going to sell pairs of shoes. I can sell 500 pairs of shoes at $40 each. And I can sell only 450 at $42. What's my elasticity? So, what's my elasticity? It's negative percent change in Q over the percent change in P. I got to figure out what was the percent change. It helps if there's a time aspect in here. When I think about a percent increase, it matters which one was the original and which one was the later. Because when you gain a 5% raise, it's 5% of your old salary, not 5% of your new salary. If you've seen these numbers in a business context, you might have done this in a different way, and that other way is good too. But here I want to think about what was my change in sales. My sales went from 500 down to 450. So we lost 50 sales. My delta Q would be down by 50. I don't want my delta Q, I want my percent delta Q. I want to say that 50 was what percent of what you used to have. Well, it used to be 500. What's 50 out of 500? That's 0.10. That's 10%. My percent change in sales was I lost 10% of my sales. What's my percent change in P? Well, we went from 40 up to 42. That's an increase of 2. 2 out of what? 2 out of 40. I want to write that as a fraction. 2 out of 40 is 1 out of 20 is 5%. So my sales went down by 10% and the price went up by 5%. The two minus signs cancel. The minus signs should always cancel. One of those things should always be negative. I get 10 over 5. I get 2. My elasticity is 2.